Welcome to part 2 of the 3D noise Flowfield in Unity tutorial by PeerPlay. In the previous part we created a grid of directions visualized with on-draw gizmos. For those of you who support me, the source files of the previous part and this part are available for download at my Patreon. In this part we are going to place our directions into a multidimensional array and apply the directions to objects that we will instantiate in the grid. Basically we will be making our own particle system. We will be changing the script a lot, so if you want, make a backup of the script we've made so far. Let's open up the noise Flowfield script. In the previous part we've calculated the Flowfield directions in the on-draw gizmos, but in this part we will do the calculations in the update. So let's create a new void and we'll call this the calculate Flowfield directions. So instead of doing the calculations in the on-draw gizmos, we're going to copy everything in this void and we're going to paste that inside of the calculate Flowfield directions. Now as this is not in the on-draw gizmos, we can remove everything here, these lines, because we don't need to apply them. And we need to call this void inside of the update. So let's write calculate Flowfield directions to run in the update. Now at this point we're not doing anything with the noise directions and we need to store them in a handy way. So the way we can do this is create a multidimensional array of vectors which has an x, y and z direction. Create a new public vector 3. Now to create a vector we just type this, but to create a multidimensional vector we can type some commas in here. So if I type 1 comma we get a 2-dimensional vector, but we want to have a 3-dimensional vector, so we can apply that to the 3-dimensional grid. So we'll type 2 commas and we'll call this the Flowfield direction. Now we need to set the size for the Flowfield directions, and we can set the size by using the grid size that we fill in into the grid size. So in the start function we'll say that the Flowfield direction is a new vector 3 and it will have the size in its x direction of the grid size dot x. We'll get the grid size dot y and we'll get the grid size dot z. Now as this is running in the update, we don't need to apply the new fast noise in the update, but we'll just do this once at start. So let's place this line here. And now that we've created the multidimensional vector array of Flowfield direction, we want to apply the noise directions to this Flowfield directions. So underneath the noise direction we're going to say that the Flowfield direction, and here we need to get its position, and the position will be the x, y and z of the loop, and we want to fill this position with the noise direction. So we'll say that it's going to be vector 3 dot normalize, and we want to get the normalize of the noise direction. Now the reason I made this multidimensional array is because we will instantiate many particles, and for each of the particle we will track its position. If the position corresponds with the Flowfield direction array, we will apply a force to the particle using the direction in the array. Now I made a silly mistake, because in the start function we assigned the Flowfield direction to a new multidimensional vector, but I used parentheses here, and that would say that this would be a new vector of 3 positions. We don't want to use the parentheses, but we want to use the brackets, because this is not just one vector, but it's a multidimensional vector. So this says what the dimensions will be of the array. Now the next thing we'll add is a cell size. This cell size will define how large the area of one direction vector is. So let's add a new public float and we'll call this cell size. Now let's make sure that we can see the size of our grid in the scene view, and we can do that with on-draw gizmos, and we're going to draw a wire cube. Let's start by selecting a color. So we'll say gizmos.color is color.white. So everything that follows this line will have this color. Now the size of the grid is the grid size multiplied by the cell size. So to create the draw wire cube, we're going to say gizmos.draw wire cube. And this has 2 different parameters. First is the center and the next one is the size of the cube. So we'll get here a vector 3. So we'll say first that this is going to be this dot transform dot position plus a new vector 3. So the first thing we need to get is the grid size in its x, so we'll say grid size dot x, and we're going to multiply this by the cell size. Now, as this is for the center, we only want to move it half of its length, so we're going to divide this entire thing by 2. So we'll say multiply by 0.5f. Now let's copy paste this entire thing, and we'll do the same for the y and the z. So y and z. So this is going to be a y and this is going to be a z. Now let's type a comma and I'll press enter for a new line, and here we have to fill in the size. So we can say a new vector 3, and for the x it will be the grid size dot x multiplied by the cell size. And for the y we'll get the grid size dot y multiplied by cell size, and for the z we'll get the grid size dot z multiplied by cell size. Now let's close the entire line, and let's close this one off with a semicolon. Now let's save the script and go back to Unity to show our wire cube. So at this point we don't see the wire cube yet because the cell size is set at 0, but if we increase this we can see the draw wire cube. Now let's set this to a size of 5, and we can change the grid size in its x, y or z. Now we are calculating 3D noise through C#, which means it uses CPU power to do this. It takes quite a lot of memory to do this, so I suggest to keep the grid size at a reasonably low resolution. To do this more efficiently, we should do all of our calculations in the shader, but for this example we are just using C#. So please keep in mind that this system is quite performance heavy. At this point the flow field doesn't do anything yet because we need to instantiate particles, creating our own particle system. Let's create a new C# script, and we're going to call this the Flowfield particle. Now let's create a particle prefab. So we're going to game object, 3D object, and select a cube. Let's remove the box collider, and we're going to add the Flowfield particle script to this cube. Now let's rename the cube to a particle. Let's create a new folder, and we're going to call this folder prefabs. Now let's drag and drop the particle in prefabs. Now in this part we won't write anything in the Flowfield particle script, we will just spawn the particles in our system. In the next part we will write our own simple physics to control the velocity of the particles. So let's go back to our noise Flowfield script. We want to spawn the particles into the grid, so let's create some variables that we need for our particles. So these are all about the particles. So first of all we need to reference the particle that we want to instantiate. So let's say public game object, and we'll call this the particle prefab. Now we also want to specify how many particles we want to instantiate. So let's create a public integer, and we'll call this the amount of particles. And to keep track of all of our particles we're going to create a list containing the Flowfield particle script. So let's say a public list, and it's going to be a list of the Flowfield particle, and we'll call this particles. Now when you create a list you also need to instantiate the new list. So in the start function we're going to say that particles is a new list of Flowfield particle. Now let's create a for loop with the length of the amount of particles. So we'll say for int I is 0, I is less than the amount of particles, I++. Let's start by creating a random position within the grid, and to do this we can start by creating a vector tree, and we'll call this the random pos, and it's going to be a new vector 3. So for the x we'll say random.range between the start position of our current transform, so we'll say this.transform.position.x, and we want it to be at a maximum of this transform plus the grid size multiplied by the cell size. So we'll say this dot transform dot position dot x plus the grid size dot x multiplied by the cell size. Now that's it for the x. Let's copy paste this line 2 times, and we just have to change these values to y, 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 and z, z, z. Now let's close this one off. Now we need to instantiate the particle, so we'll say game object, and we'll call this the particle instance, and this is casted to a game object instantiate, and we need to get the particle prefab here. Now we'll set the particle instance to the random pos, so we'll say particle instance dot its transform dot its position is the random pos. Then we'll parent this object to this current transform, so we'll say that particle instance dot transform dot parent is this dot transform. And we might also want to set the scale, so let's add another variable and we'll call this public float, and let's call this the particle scale. Let's actually make this list hidden in the inspector, so we'll say hide in inspector. Now let's talk to the particle instance again. Let me scroll down a little bit. So particle instance dot its transform dot its local scale is a new vector 3 with the particle scale, and particle scale and particle scale. Now let's add the component Flowfield particle to the particle list. So we'll say particles dot add, and we're going to add the particle instance dot get component Flowfield particle. Now they should spawn a lot of objects inside of the wire cube. Now when we save this script, it will give an error because I used copy paste and I forgot to remove this last comma here. So with that removed, let's save the script and it won't throw an error, and go back to Unity. Now back in Unity, let's remove this particle, we don't need it, and on the noise flow field we need to select the prefab. So let's drag and drop that into the particle prefab. We're going to set the amount of particles to spawn, so we'll say like 1000, and we'll set the particle scale to 1 for now. And let's run that. And now you can see that it spawned a lot of cubes inside of the wire cube. But there is still a problem. Because we are setting random positions, some cubes are appearing inside of other cubes, because they might have the same random position or almost the same. To avoid this, we are going to check the random position chosen against all the positions in the list of particles, and if it's outside of a certain radius, it will place the particle. If not, it will find another location until it can't find any new open positions. So let's stop this and go back to the Flowfield script. So to create this, we're going to add a boolean that will check if the random position is a valid position. So let's create a bool. We'll type bool, and we'll call this the particle spawn validation. And this will take in a vector 3, and we'll call this position. So inside of this boolean, we're going to do a distance check against all the other particles. So we'll do this by making a for each loop, and inside of the for each loop we're going to say that a Flowfield particle called particle in the list particles. So for each of these we're going to do a distance check. So if vector 3 dot distance between the position that we take into the particle spawn validation, which will be the random pos actually, if this distance between this one and the particle dot transform dot position is less than a certain amount, and for that we need another float. So let's create a public float and we'll call this the spawn radius. We'll type here the spawn radius. Now let's create a bool in a bool. Yes, we're going to do that. A bool valid, we'll call it valid, is true. So if this statement is true, then that means that our particle position that we want to spawn is inside of the radius of a spawn particle. Then we want to set the valid to false. And we're gonna break out of the loop because we don't need to check on anything else. Now if after the for each loop valid is still true, we're going to check if valid is still true. So if valid, then we're going to return this boolean to true. Else, we're going to return false. Now let's scroll down to the start. So here we're going to implement this. So we first create the random position, and then we'll create a new temporary boolean, and we'll call this boolean is valid, and that is going to be the particle spawn validation. So this statement is going to do a check against all other positions, and if it's a valid, then this will return true and either false. So based on this boolean we can do something else. If it's valid, so we're going to make an if statement. If is valid, then we want to do all of these things. Now at this point it will just run one time, so it will do a check, and if it's inside of the position of another particle, then it will do nothing and spawn no particle, and it will try to spawn another one, but the loop will increase, so we don't get the amount of particles that we want. So we want to do this check a couple of times, and we can do this by adding a while loop. So and for that we're going to create another integer inside of the for loop, and we'll call this attempt. And we're going to set attempt to 0. Now we'll do a while loop. So while the attempt is under the amount of attempts that we want to do, so let's say we'll do 100 attempts. We'll put everything inside the while loop. If it's valid, we want to break out of this while loop, so we should type break here. But if it's not valid, we need to add to the attempt. So we'll say if is valid with the exclamation mark in front of it, so it's the opposite of the statement. Let me scroll down a little bit, and we'll say attempt plus plus. So at the end of the for loop we can debug how many particles we actually instantiated. So we'll say debug.log, and we want to log the particles list dot count. So with that in place, let's save the script and go back to Unity. So now we can be sure that if we set the spawn radius high enough that no other particle will be inside another particle. So if we set the spawn radius at, for example, 2, that means that the distance between the particles will have to be at least 2. We'll run it, and we can see that we've spawned 1,000 of cubes, and they are all at different positions from each other. They have some spacing between them, so that's nice. Now let's try it with a radius of 10. And now you can see that it only spawned 126 cubes, because the spawn radius around it has to be 10. Now probably if I run this again, it might find a different amount of cubes. Yes, now it found 132. That's it for this part. In the next part we will make the particles move through the grid using the noise directions. When they hit the edge of the grid, they will appear on the opposite side, keeping them inside the flow field. Thank you for watching this tutorial part. Don't forget to like the video and subscribe to the channel if you haven't already. If you would like to support me creating these tutorials, you can become a patron on my Patreon. You'll then get access to the source files of the tutorials. Happy coding!